Everybody, my name is David Plus. I'm a Principal Program Manager, and we're going to cover built-in intelligence with Azure SQL and SQL Server 2022. So here's our agenda. There's a lot. It's going to try to make this very practical. So we're going to talk about Query Store and some aspects of Query Store. How many of y'all are, bless you, how many of y'all are using Query Store? That's awesome. So for those that didn't raise their hand, why not? I'd love to know that. Tell me later. You should use it. It's the DBA's best friend. It is just great for performance and understanding what's going on with your queries, giving you a good query history and helping you migrate. So we'll talk about the aspects of it being on by default and then talk about Query Store hints, and I want to do a demo of that. Then I want to talk about the history of database compatibility and intelligent query processing. We see these as two separate families, and we'll explain what that means. Then I'm going to get into like the intelligent query processing feature set, in particular around SQL Server 2022. Okay, so let's talk about Query Store on by default. So it simplifies performance tuning across the customer experience. I mean, you capture queries, execution plans, runtime statistics, and it's all asynchronous. And that's been the case since SQL Server 2016, but we've just made it a lot easier and a lot streamlined over time. And when we say Query Store on by default, just know it is on by default for new databases. You still have to opt in if you're backing up and restoring a database from a prior release. Okay. So one of the first concerns you hear logically is the overhead of having it on for all user databases. Again, like I said, plans, text, and performance data is all asynchronous. But keep in mind that Query Store being on by default has been a standard in Azure SQL for the very beginning. And we see that through the portal experience is Query Performance Insights, but it's still Query Store. So if you were to connect through Management Studio, you'd still see Query Store. So we know it's been this way in Azure SQL for a very, very long time. The other thing too, and I kind of did a poll of the group before we started, there's a bulk of the folks in here that are on 2019. With 2019, we have better, more refined capture components. So instead of capturing everything, it's auto. The max size is changed from 100 to 1 gig. When we say auto, for 1 second compiles, 100 milliseconds for execution CPU time, and 30 executions for the execution count for what it's capturing. We also had a number of scenarios with cumulative update 6, 8, and 9 that we've done a lot more refinements to it. So the concern about it being on should be greatly minimized. If you are still concerned about it, we do have the concept of a custom capture policy, which you can do further refining. That's been in the product for a little bit. So if you want to like further hone down what's being captured, if you're concerned about overhead, this could certainly be a way of doing that. Okay. So they've been available for a while. So if you have an environment, let's say with like a heavy ad hoc workloads, and you're just worried that there could be a high cost of the Query Store capture, you can use custom capture policies to be very selective about what you capture and only pick the most expensive ones, right? Maybe things that have been repeated often or excessive in any way. So that's what you can do with a custom capture policy. All right, so let's talk about Query Store hints. And I'm going to try to get into the dangers here too. I want to talk about query hints in general. So we use query hints to influence plan behavior. Many of us are already doing this, developers especially, vendors, are leveraging hints in our code to influence plan behavior. They're specified via the option clause, and while they do help provide solutions for performance related issues, they also require changing the text, the query text that is. So why interfere with the optimization process? Ideally, the optimizer is going to pick an execution plan that's optimal for a query. This is what it's designed to do, but it doesn't always happen. And when it doesn't happen, a DBA may need to optimize for a specific condition, or they get stuck with a bad plan, and bad plans lead to bad performance. As I've heard it said before, a bad plan is not the one that fails, but the one that succeeds at the greatest cost. Okay, it's kind of like almost a DBA credo. So the thing is, though, if we are influencing planned behavior, is that true all the time? So we can agree that distribution of statistics matters, volume of data matters, workloads matter, the resources that you have on the system matter. Cumulative updates could change things, right? Going from one release to another matters. But when you put that hint in there and you're telling it to do this every time, be careful with what you're doing here. And I would say that you should always kind of go back and reassess these things over time, right? Now, it does make sense. Like, you could need to recompile, which is a very common way of addressing things, especially if you have like a parameter sniffing issue or something like that. You may need to put a limit on a memory grant size for like a bulk insert operation. You may need to limit the max DOP. Maybe if you have a mixed workload for both reporting and OLTP, you put max DOP on a particular query for a particular report. Or maybe you're saying, hey, this one query, I want it to use DB compat 110 or 120 because it behaves better that way. But everything else, let's use the latest compatibility level. That's another kind of approach to use with hints. Okay. Now, there's many reasons to leverage hints, but they do require making changes. It's not something that can necessarily just be done blindly, certainly not without vendor support. Now, you can't often change these directly with T-SQL code, because often cases, if you do this and you're hard coding something, you could invalidate your vendor relationship. So what do DBAs often use, or I shouldn't say often, could use? Plan guides. How many of y'all have leveraged plan guides? Okay, so there's a fair number of people in this room. 3 hands went up. Do you know how long plan guides have been out? Like since 2008. They're not easy to use. I'm not going to do a plan guide demo. Feel free to go look that technology up. Generally speaking, if someone's used plan guides, I'll ask the same group of people, how many of you did it because CSS told you to? And it's the same hands. It's the same people. So they weren't easy to use, and they were generally driven by CSS helping someone maintain a planned behavior for some particular reason, which we will come back for. Now, query store hints essentially makes what was attempted to be done via plan guides a lot better, a lot more scalable, and just frankly way easier to use. Okay, so it's a direct method for developers and DBAs to shape query plans without changing code. That's what query store hints lets you do. It's a lot safer. So it's a feature that extends query store. It means you do need query store, because that's your persistence, is that query store black box recorder that's part of your database, that follows your database. That's what query store hints is leveraging. They are persisted, they will survive restarts, and query store hints are just way easier to use. What's also interesting is query store hints will override other hard-coded statement level hints and plan guides. So let's say that there's a hint that has been introduced in some other way, or a plan guide that was introduced in some other way, and you've discovered that's causing you a problem. You can kind of like use it to knock that hint out of the way via query store hint. Especially could be done for troubleshooting, stopgap measure. Hopefully you don't have to do that long term. I think that's kind of weird for that to be a long-term solution, but it can be done to help you in that regard as well. Okay. So how do you use it? What's the process? How does this work? Query gets executed. We capture query plans that are captured in query store, right? This is all that asynchronous stuff with the text, the plan, the runtime history. The DBA creates a query store hint on a query, and then the query executes using that query store hint. So how does the DBA do this? Currently, they identify the query store query ID. They can use the query store catalog views or management studio. And then they execute the SP query store hint stored procedure with the query ID and essentially one or more hints that they want to influence. And if y'all see there on the screen, That's a scenario where we're leveraging two hints. I'm saying use maxstop 1 and use compat level 120 for that particular query. Does not require a restart. It'll persist it, and it does it immediately. If you need to clear it, it's really easy to clear it as well. I'll show you all what that looks like. Actually, we'll take a look now. Okay, so I'm going to go back. Some of these I'm doing live, by the way. All right, so I have this property MLS database. I'm going to just clear everything out. I'm going to set the compat level to be 150 in this particular case. My point here, why am I doing 150? You do not need a compatibility level to take advantage of query store hints. That's huge. This is not bound to compat level, okay? So I've got to have read-write for my query store, and it is read-write, okay? So I'm going to drop this extended event session. I'll recreate it and start it. And I said start it. All I had to do is scroll down. Let's take a look at property MLS. That's the database that we're in. Okay. Just kind of expand that out. Go into extended event sessions here. And it is this one here. And I'm going to watch live data. Okay. Bounce back over here. And what I want you to see first is there's no existing hints. I cleared all that out. Okay, there's nothing here. Right? I'm going to go back over here. And what I'm going to look at is this index, this non-clustered index on property agent ID. Okay, and I'm going to look at the histogram here, the statistics that is. And I'm going to see that there's a particular value where the distribution of the data is really, really off compared to everything else. So all the way down here at the bottom, you see this guy? It's like 100,000 rows compared to everything else. Everything else is like 3-4 records. So what happens when I run this with agent 101, which is 100,000 records, you're probably going to guess I'm going to get a table scan, which would make sense. So let's test that out. I'm going to include the actual execution plan and run this. And there's my table scan. Now we've cached that plan as SQL Server does. And that means when I run this one, and let's just take a look and see this here, right? Yep, 100,000 records. So now I'm going to run this one. And it's only 3 records back, but I still did that table scan. And we all know, we've seen this experience, right? So I could change the query code, but let's say if this is a vendor app, I would be invalidating something. So what I'm going to do is run this query to find the query ID, and the query ID looks to be 6 here. So what I'll do is find that query ID, it's 6. And for that, I'm going to add the option recompile. Now, let's check to make sure that hint exists. And it does. Okay. Query ID 6. And now let's execute these two again together. And when I look at the execution plan, the first one is a table scan, and the second one is a bookmark lookup, which would be optimal for that second scenario. It's exactly what I want. And so if these queries got ran in reverse, I would get the same thing. I'd get the bookmark lookup first, and then I would get the table scan secondarily, because that's what the recompile is doing for me. I'm okay with the compilation time to give me this experience. What's beautiful about this is I didn't change code. So again, here's how to see this hint in place. If I want to clear it, I can clear it this easy. It's this easy to clear it. I think y'all trust that I've cleared it, and I can prove it by just running these two again. And I mean, I could even reverse it, right? Let's say this is 4, let's reverse it, and now this is 101. Some ad hoc going on in my demo, right? This case, I cached the bookmark lookup. Oh, that's interesting. And then I got the table scan there. Okay. Oh, is it? Oh, thank you. Thank you for catching that. Yeah. I didn't clear it. I cleared 4, didn't I? Ah, good eye, y'all. Good eye. So this makes it even better demo. Y'all just. So now let's go here. DBA had an error. Lovely. Boom. That's got to be the coolest ad hoc error improved demo I think I've ever had. There you go. Yeah, and that's exactly the way it works. So again, and there's a best practice there, right, to keep your eye on that. So this is all query ID 4. So if I make this query ID 6, as we know it should be, I will highlight this, and let's run that. And then I'm just going to quickly show y'all 2 things. One, make sure I get this right. There's that query hint now with multiple scenarios in here, right? And remember I started that extended event? Well, there's all my extended event history showing like, hey, there's that option recompile. And then when I went in there and did it in reverse the other way for query ID 6, right? Cool. I mean, and to me, this was one of the features that I helped drive. There's one Achilles heel with it, and currently is optimize for. That query hint in particular does not work currently in query store hints. It's the only one that is of issue. Cool. So not only are y'all here at 9 in the morning, you are aware and watching. All right, so let's talk about a history of intelligent database, and this was really important for me to fit in here. I'm going to show my age with this next slide. I told you there's 2 families, right? So there is a family of database compatibility levels, and the reason why I made a point to bring this up is, guess what the most popular database compatibility level is? Guess what? Across all versions of SQL. 100. So most customers on later builds of SQL Server are still using 100. Most customers have no idea that they're doing that. Yeah. So for the consultants in the room, that's a huge hint. Okay. There's double sprinkles on 160. That's the target. That's what I think y'all should be trying to get to. And this is a slide that I put together. I will be happy to give this to y'all. And I am happy for you to present this anywhere you want. Because I'm driving a point here, and this is where insert opinion here. This is like a slide that I did. 80 compatibility level got you from 200 to from 2000 to 2008 R2. 2005 got you from, or 90 compatibility mode got you from 2005 to 2012. 100 though gets you all the way from 2008 all the way to 2022. It's almost like a bridge. Okay, here's the problem though. Adaptive query processing and intelligent query processing started at 140. So if for that scenario everything is 100, you're not taking advantage of any of the next gen compat level scenarios, next gen IQP scenarios, because the idea is that you're keeping and maintaining the experience of the compat level that you were at. This is true in Azure SQL too. They're not moving the stuff automatically. The compat level is one thing that you do need to opt in for, because we have a principle of do no harm. Problem is that if you don't make that adjustment, you're not taking advantage of all this stuff. So again, I'm more than happy for y'all to take this slide and present it anywhere you want and do whatever you want with it, because I think it is that important. Okay, now here's the next family. This is the family of features. And I'm kind of like looking at that 2017, 140, 150, 160, 2017, 2019, 2022. We're starting with 2017 and 19. We called it adaptive query processing in 2017. The change of the branding to intelligent query processing starting in 2019. You get these capabilities, and then in 2022, we added more. Thank you. Well, what's the key point here? Available by default on the latest compatibility level setting. Okay, so if I create a database on SQL Server 2022, it's going to be 160. Broad impact improves the performance of existing workload with zero implementation effort. Once you get into that compat level, you're going to get that, get those IQP family of features. And critical parallel workloads improve running at scale while remaining adaptive to changes in the data. That is the goal of any of these improvements coming to fruition. Definitely go to IQP demos. All of your core demos are going to be there, and you can take advantage of those, and feel free to show others in your organization. Here are the 2022 capabilities. Notice that there's kind of a box around memory grant feedback. That means that we also improved memory grant feedback for row mode and batch mode in 2022. I know that that was released row mode, batch mode in 2017, 2019, but there's improvements to that. The additional things are degree of parallelism feedback, cardinality estimate feedback, approximate percentile, parameter sensitive plan optimization, and optimized plan forcing, which I'm going to try my best to go through as much of this as possible. So we'll start with, because we're time bound, we'll start with parameter sensitive plan optimization. So parameter sniffing. So SQL Server sniffs the current parameter during compilation or recompilation and passes it to the optimizer. So what's sniffed can be used to generate efficient query plans. I've seen it kind of said that parameter sniffing is almost suggested that it's a bad thing. It's an optimization. So parameter sniffing is not the problem. It's what it ends up smelling like that's the problem, I like to say. So if you sniff something that's not optimal and we end up caching and reusing, that non-optimal smell or whatever you want to look at is in the form of a bad plan, and that's when we run into performance issues. So what's optimal for the current execution is not necessarily optimal for subsequent executions. See, also the reason why I'm wary of forcing things, forcing a hint, even so far as forcing something in Query Store, because is it true every time? So it's got to be a careful decision. Now, in reverse, there was a reason why I kind of reversed that demo previously, because I wanted you to think about this. So if I did in reverse that new compile on agent ID 4 with only a handful of records, when I cache that plan and use it for the next one, that is not optimal at all. What I want it to see is you have a distribution of data. Let's adjust for that. But I've only been caching one plan up until this point, and that's always been the struggle. It makes it what's not optimal. So if I could get a new compile, you could force that with a recompile, but perhaps there would be another way through another optimization. Now, how we've tackled this for such a long time, here's another insert opinion here kind of thing. In my opinion, the ones that put the double sprinkles on are the ones that are the best to use. And I can give you, and again, this is my take on this. Compilation, for the most part, is fairly cheap at this point. So statement level, batch level compilation, it doesn't have nearly as much overhead as it had in the past. Optimize for a value. If you know what that value is, if you've done the due diligence and it's fairly stable, you can do that. Everything else on the top, optimize for unknown. I have not seen that be a better scenario than doing a recompile, to be frank, because essentially it's the average of the histogram, and it's just like you're sort of settling for the average. Does it give you stability? Yes, but you're sort of settling for the average. Disabling parameter sniffing, I don't know how that's necessarily a strong approach, especially on a really big system. Everything else, keep fixed plan, force a known plan, forcing a known plan with like a plan guides, those are hard to use. And then nested procedures and dynamic string execution, yeah, if you have control of the code, maybe that would work. You can kind of see why I'm picking recompile and optimize for is the typically a good scenario for DBAs. So let's get into parameter-sensitive plan optimization. So what we're doing is enabling multiple active plans for a single parameterized statement. Cached execution plans can accommodate different data sizes based on the runtime parameters, and this is an improvement under database compatibility 160. Let's say that you can't get to 160. What could you probably do? Use a query store hint. So let's say you can't get to 160, you do that recompile approach that I showed you before, right? Awesome. So there are some limitations. There's a maximum of 200 plans in query store with 27 in cache. So we wanted to make sure that we didn't create cache bloat, so we limited the number of plans in cache. We also don't want the overhead of trying to do parameter-sensitive plan optimization to outweigh any downstream benefits. So again, do no harm. That's our motto. And the feature had to be also compatible with query store, right? And query store plan forcing. So essentially what we're doing is bucketizing the data. So what we're looking at is scenarios with a large amount, medium to small amount of data, and we're bucketizing it to find the scenarios where query performance is identified through these data distributions and any at-risk predicates. So the column statistic histograms are used to create up to 3 scenarios of these available predicates. And then there's a dispatcher plan that maps to the query variance based on predicates cardinality range values. And you can actually see that in the execution plan itself. When parameter-sensitive plan optimization kicks in query store, you can even see multiple plans being used. There's also an extended event that allows you to track for this. Okay, so there's also scenarios where parameter-sensitive plan optimization won't kick in, so you'll be able to see why that was skipped in that regard as well. Okay. All right, so let's talk about like the feedback set of scenarios, query performance feedback. So this is like a set of siblings that all have the same feedback mechanisms. One of them uses query store hints and the other 2 uses query store for metadata. These 3 are memory grant feedback, degree of parallelism feedback, and CE cardinality feedback. So they all work the same way. User executes a query qualifies for the feedback, possible changes are suggested, they're evaluated. If they improve performance, they're verified and persisted. If they don't, they're not used. And it's constantly being evaluated. So you can actually see this as you're monitoring the catalog views, and you can actually see this through extended events, this kind of mechanism being in place, which is awesome. This is why I'm talking about it like this subset of the family, the feedback siblings, if you were. And so let's go into the first one, memory grant feedback percentile and persistence, which is an improvement over the previous memory grant feedback scenario. So memory grant feedback was a feature that was first introduced in 2017, and we've expanded its scope. The feedback works more efficiently than when we first persisted the feedback in query store. Actually now that's what we're doing. And then we use a query execution history to determine a better grant size. So if you don't get enough memory for a query, then your query will spill to disk. That always means tempDB, okay? If you get too much of a query, then that's less memory for other queries needing grants. So it's the too much, too few problem. So what we want is efficiency, and that's what memory grant feedback percentile persistence gives us. So here's what the scenario was in the past, okay? And it's pretty straightforward here. Without memory grant percentile grant feedback, we only look at the previous execution of a query to determine the memory grant. So you get this waffling effect. So if it's like, okay, I need a lot, now I need a little bit. Now I need a lot, now I need a little bit. You're just being bounced around and you're only being given the last message, the last known good scenario, and you end up waffling back and forth, which is not efficient. So with memory grant feedback percentile grant, it sees this and starts smoothing it out over time. It's like, wait a second, I see what's going on here. let me give you a recommendation based on this history to be more efficient. And all you have to do is get to the latest compatibility level. Actually, some of this stuff is improved just being on SQL Server 2022 because we improve the previous memory grant feedback mechanisms. Okay. So let's talk about the next one. This is degree of parallelism feedback. This one we actually have a demo. So parallelism is often beneficial for reporting and analytic queries. Otherwise, large amounts of data, OLTP-centric queries would suffer when time is spent coordinating all these threads, right? So that outweighs the advantages of using a parallel plan. Before 2019, the default was max.0, so basically use everything. With 2019, a calculation is done at setup time, and in Azure, it's 8 for Azure SQL database. Thing is there's really still no adjustment in an attempt to get it to the right degree of parallelism for a particular query, okay? So, yeah, so before 2019, max.0, use everything. And with 2019, there's a calculation at setup time based on available processors, 8 in Azure SQL database. So this is essentially what we're doing. In 2022, we can identify and address parallel inefficiencies in queries that use too much parallelism. Wasted parallelism drives compute overhead, so using a lower degree of parallelism can be more efficient. If we determine that we're using too much parallelism, we try a lower degree of parallelism, not going below 2. So essentially what we're doing is we're laddering down. We're testing and laddering down, okay? We never go up though, we only reduce. We don't recompile any plans or revalidate, and we never exceed the max DOP configuration for the server or a query. So you could look at that as the ceiling. So if you set the max DOP to a particular level, we're not going to go below. We're not going to go. We're never going to exceed that. Is the point? Okay. So let's go through a demo on this one. Now this demo took 45 minutes to complete. So I time boxed this thing, and I want you to me, there's a reason I didn't show demos on the other two, because it sort of got sandwiched into this recording I did, and I found it interesting that actually happened. So what I do is say, hey, max.0, use everything, clear out everything in query store, make sure I'm using dbcompat 160. Here's the stored procedure I'm using, the supplier ID. It's a very simple stored procedure. By the way, this data has been way, just expanded, I mean, dramatically. I just blew this up. I set an extended event session. I'm not in y'all's way, right? Okay. Yeah, so here we go. So this, so I've started this up and I'm gonna watch live data. This is really, really important. It's a key part of this demo. And now I'm gonna run a command prompt, and I'm just gonna pass in some workload that I'm doing through OStress. And I use Power Toys to keep the command window up front. So it's got this, so that's why I'm pinning it here. And there's a reason for that, you'll see. So that's the catalog view, query store plan feedback. And I'm doing this workload here. The first thing that came in is CE feedback. So it's saying the verification is regressed. Okay, so there's a message for CE feedback that popped in first while this workload is going on. Okay, now I got a memory grant feedback message. So it's giving me a message here of, so it's evaluating the amount of memory for that particular scenario, okay? I got some feedback, so it's testing 48, and it's saying that that's the last good feedback. The baseline was 64, it's going like, you know what? I think we can do good with 48. Let's keep working on that. So we're gonna test, or we're gonna record, we're gonna keep at it. So I got another, okay, so now it's testing 32. Maybe 32 is going to work. So let's test and measure and record. That's what it's doing here. So if you look at the timestamp here, you can see how long this is running. Okay, so we had 48, now we have 32. The baseline was 64. We're continuing to go through this. We're continuing to test. And the same method is used to track CE feedback and memory grant feedback as well, as you see here. Okay, now we're testing 20. So it's going to see if 20 is going to work. So now we're at 20. So it's looking at this whole time. Now notice something about this catalog view. It updates. So it's not going to give me a record for everyone because it's in JSON. It would just bloat it up. So we're doing an update here, but we see the performance improvement. We see the laddering effect in extended events. Now on top of that, I can go to my performance history and look at what we're seeing in this performance history query. Start at 64, and now I can see the history, and I can see that the performance has improved over time. So we're just like, how much can I squeeze out of this and only give it what it absolutely needs from a DOP feedback perspective, from a memory grant feedback perspective, and using the correct model from a CE feedback perspective, because we're about to learn that one model does not rule them all, okay? Now, I'm not going to be able to go through this deep. Kate Smith, one of my colleagues, did a deep dive on 8KB. Basically, this entire track here, CE feedback by itself for an entire hour. So this is a deep topic, and it goes deeper. So the high piece here is one model does not fit all scenarios. When we talk about a model, it's a basic set of assumptions that we use to interpret statistics and make estimates as we combine expressions within a query tree. So we have assumptions that we use because that's the framework and how we interact with statistical data that's already been received. So historically, there's always been one model for CE, and it's always been that same model, but the challenge is that cardinality estimation hits inside of workload, and some queries are going to work better with one model, and some queries work better with a different one. So we end up having a problem with that. So CE feedback, first of all, the cardinality estimation is how the optimizer estimates the total number of rows being processed in the query plan. So we know one model can't rule them all and perform well. So CE feedback in 2022 helps improve this by addressing suboptimal plans caused by incorrect assumptions. So the CE feedback adapts to characteristics of a given query and the data distribution to identify a more appropriate model for improved performance. So the CE feedback, and the key thing here is it reduces regression risk when upgrading for older versions of the database engine. I can't tell you how many times in the past I saw someone go to a later compat level and quickly have to go back because they're like, yeah, queries are blowing up. Some queries are running better, but some of our key ones aren't. So CE feedback helps address that scenario. Okay, so CE feedback identifies model-related assumptions and evaluates whether they're accurate for repeating queries. If an assumption looks incorrect, the subsequent execution of the model is tested with a query plan that adjusts the impactful CE model and verifies that it helps. Very similar to what we saw with the other feedback mechanisms, right? If the model improves plan quality, the old query is replaced with a query plan that uses the appropriate, guess what? Query store hint. That is the mechanism it uses to adjust the model. So it's using that technology that we showed very early on to implement the CE feedback solution. So again, Kate has a deep dive on this. These are the model scenarios that CE feedback is looking at: correlation, join containment, and optimized row goal. I definitely would look at MS-DOC's version of the CE And Kate has a great talk on cardinality estimation, a comprehensive look. Key thing is if you're just looking at, hey, I just want to get this because I know I'm running into this problem, SQL Server 2022, DB Compat 160, okay? Otherwise, yeah, I would go through this, and this is kind of the deep dive of what you're looking at. I think I'm at 10 minutes, am I right?
Yes.
Thank you. Okay, so how do we leverage this? Ensure database compatibility level 160 is enabled, and enable query store in read-write mode. We saw that before in the previous demos. CE feedback activity can be monitored through the feedback analysis and feedback validation extended events. You also saw that. You saw that extended event pop up as well in the previous demo. The sys query store query hints and query store plan feedback catalog views can be used to track this. So we have user query store hints, and we have system-based query store hints. System-based coming from the CE feedback mechanism. Now you can disable CE feedback on the database level. You can turn it on and off using this, or you can disable it at the query level, disable CE feedback query hint. CE feedback won't be used for a query with forced query plans to the query store or hard-coded user set query hints. Remember, like we talked about this right at the beginning, be careful when you start forcing things because you're taking the optimizer's capabilities out of its hands, and it's only going to do what you're forcing it to do. So that's why I put this in red. I want you to let the optimizer evaluate these things. If it's a problem and you know that you need to keep that scenario, by all means keep it. I'm also not suggesting that you go in and rip everything out from your previous application database. I'm not suggesting that either. What I'm suggesting is evaluate, especially if your data distribution changes, especially if your version of SQL Server changes, if your conditions change. Because conditions mean statistics, resource changes means the optimizer is going to potentially look at a scenario different. Memory matters, things like that. Compute parallelism matters. So make sure that you are evaluating any scenario that forces a query to move in a particular direction. So things like CE feedback can actually work. Okay, so let's talk about some of these other scenarios. We're getting close to time. Optimize plan forcing. So for higher complex queries with long compilation times, so like think of scenarios where customers experience high duration queries and increased resource utilization in what we call a compile storm. So have y'all ever had a box, the highly busy OLTP scenario? Either it's forced to reboot or fail over unexpectedly. And then when everyone comes back in again, all the queries that we're compiling creates this nightmare wall of compile overhead. That's what we're talking about here, trying to adjust for this. So that's that compile storm that I talk about. So it will drive up CPU usage, and if the queries are also running in parallel, it can also drive up memory overhead too because of the memory grants it needs. It's a total mess. I've seen it. It's one of those things that DBAs can have to run with. So sometimes they'll have to warm the cache, so to speak, to try to address this, but it would be nice if we had a better way. Okay, so to address this problem, we have optimized plan forcing using query store. So the one thing to remember here is that we're trying to save time during the optimization process. So the goal is to address a problem where you have a query that takes a long time to compile because it's complex and the query plan gets kicked out of memory. So then guess what? You get to recompile all over again, right? The compilation process, compiling of it in general is going to be CPU intensive. And like I said, potentially memory intensive. So with optimized plan forcing, what we're trying to do is speed up that process for anything for queries that have been forced. And to do that, we're capturing what we call a replay script, which is basically we're saving replay for important optimization rules. We save these rules in a hidden attribute in the show plan XML. So when the query gets run again, we just look at the replay script and execute the rules that SQL Server Engine would have typically done during the normal compilation process. So instead of having to go through a whole bunch of rules and figure things out, what we do is say, well, we already have this stuff recorded. Why don't we just replay it directly, which will save time? I mean, that's essentially what it's doing. I know it's called a script, but it's actually hidden, a hidden attribute in the show plan XML. Okay, so last topic. This is amazing that we're actually going to hit time. Last topic is approximate query processing. So this is a T-SQL scenario, but we're actually using query processing advancements to actually make this a thing. This actually just got released on SQLDB and MI. So if you have any of these scenarios, like KPI, telemetry dashboards, any kind of data science scenarios, anomaly detection, any scenarios where you're going through a massive amount of data and you're looking at doing one of these, you just need an approximate measure. I don't need my KPI to be dogged down because you're scanning through millions and millions and millions of records and doing all these calculations and trying to give me this precise measurement when I've just missed my mark anyway. I just could have, if you just would have given me an approximation, this would have gone a lot better. That's what Approximate QP is doing here. So Azure SQL DB and MI now has this. I think it went live March 1st, March 2nd, something like that. So we've made available a prox percentile function. The function calculates percentiles, and it has two forms. It's the approximate percentile CONT and prox percentile disc, DISC. The functions use less memory and CPU as compared to the precise analytic counterparts, which are more accurate. So if you don't need the accuracy, then it's going to take a fraction of the time to execute. So overall, approx percentile functions are useful in applications, the response time of percentile calc is far more important than the accuracy of the result, essentially. So because I have a little bit of time, I actually think I can show y'all this. I didn't put a demo thing in there, a demo slide in there, because I was afraid I wouldn't be able to do this. Let's take a look. Look at the date time stamp on that. Okay, so, all right. So essentially, this is what you would have using the previous functions, okay? So for this function, look at the work file and work table. Look at the scan count and the logical reads for that work table. Okay, look at how long this runs. It runs just over 6.3 seconds, right? Now I do the same thing using the approximate percentile. It only took 1.4 seconds. Look at the work table and look at the work file. I mean, it's nothing. The order history scan is exactly the same. Right? Or relatively close. No, it is exactly the same. So what this is 1.4 versus 6.3 seconds, significantly reduced I/O. Without approximation, the work table is needed. That was 99.56 of the logical reads, putting additional pressure on tempdb. Work tables, work files are always in tempdb. Okay. And I think I can just run this really quick just so y'all can see it run. I think this is on, actually we'll run both because it's on worldwide importers. And I know I'm going to hit time right when I do this, so this is perfect. 5, 6, right? Versus the approximate approach. So if you have any of those scenarios, those KPI scenarios that we talked about before, I mean, how much better is this? Done. And we're at time. Thank you, everybody. I appreciate it. And afterwards, I'll head down. Yep.